if it's done in a way that sounds human to us, then we immediately infuse that with it's got intelligence.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human.
Make you question everything.
I've seen like a realization of the power of the technology, and people kind of then move to, oh wow, it's so powerful, how we're going to control it.
Yeah.
And when I spoke to Stephen, he said to me, the person you need to speak to is Gemma. One of the best managers in Europe, of the technical teams who are at the front line of helping organizations work out how to use this artificial intelligence technology. And I thought, amazing. So we met, and then I spoke to some of your team, and their insights on you is that you're an amazing mentor, super willing to help, and extremely knowledgeable. And I immediately thought, this knowledgeable, maybe we can leverage that to share some information. And what I would say is, Gemma, that, and this is maybe slightly controversial, but in corporates, usually you get these managers who are either brilliant at managing upwards or brilliant at managing downwards. And when they're managing upwards, they're kind of managing their own trajectory upwards. Yeah. And the ones who are managing downwards are usually highly empathetic, sensitive people who want to build great teams. You're one of the few people I've spoken to who seem to be doing it both trajectories really well.
One of the things I've really, from a people point of view, one of the things I've really enjoyed throughout my time in the industry has been working with people and sharing knowledge. You know, you talk about people sort of managing up, managing down. You also get people who go, well, this is my sphere of understanding, and I don't want to let other people, because that's my unique thing. And as far as I'm concerned, if I've done a perfect job of skilling up the people around me, then I've engineered myself out of a job. But of course, if I'm good at doing that, then all I'm going to do is to engineer myself into the next job.
And you seem to have done it for an extended period.
Yeah. Yeah. So from I mean, there was stacks of stuff I did before moving into the data space, but having moved into data, I started off doing database and databases, data warehouses, and then into big data and Hadoop and analytics and data governance, and sort of broadening out from there and picking up the technologies and where the industry's moving. And of course now that's Gen AI. So we've been through, we've been using AI for forever in some form or another, machine learning. So when I came into the data space, I was just thinking about it the other day. The first main sort of customer or client environment I worked on was the database that was supporting the Boots Advantage card data and the analytics around that. And so, early sort of involvement in what we back in the day called data mining, and it was all around understanding how people, what people are buying and how frequently they're buying it, and this is way before the Amazon, people who bought this have also bought
prescriptive analytics.
Yeah.
And kind of machine learning's been around a long time. Why do you think Gen AI has captured the attention of so many people and seems to be tapping into this dystopian, like, human fear of something that's beyond a piece of technology, but something that could potentially shape civilization and the way we actually live and interact with each other?
It's the natural language. For me, it's the natural language side of it. So, we've had natural language processing in forms for decades, but the quality of a Gen AI, a large language model, in terms of how it responds and generates an answer, with language that we immediately relate to, and we are very good at anthropomorphizing things, whether it's kittens or monkeys or
Humanizing
whatever,
things.
humanizing things that aren't human. And if we've got a linguistic response from a system that is good enough, whether it's typed or whether it's spoken, if it's done in a way that sounds human to us, then we immediately infuse that with it's got intelligence. And then,
the ability to use language is almost like a handshake in a relationship that is setting out a bilateral perception of intellectual capability. Would you?
Yes, rightly or wrongly. I've got experience of working with autistic people, and when language is with autistic people, some people really struggle with the language at all, and there is a general perception as to therefore about their intelligence. But then you've got people on the autistic spectrum who are extremely linguistically capable, and then there is a perception then that therefore they must understand the social interactions and things which autistic people struggle with. And so we do have this the way a person or a thing talks to us, we inevitably infuse a level of we make assumptions about that
We
person
do.
or that somebody speaks with a particular accent. We know call centers, they try to employ people with certain accents because they're better or they're deemed to be better at or provide a better user experience, if you like, for the clients calling in.
This is a fascinating lens on it. It's the fact that so what we're saying is we've got this huge set of tools, AI, machine learning, deep learning, algorithms, sort of stuff, and until very recently they've been surfaced, in algorithms, in applications, within systems, potentially not even surfaced, the value of them surfaced.
Yeah.
But there's been a profound moment where pre-trained transformers have surfaced those systems with natural language.
Yeah.
And your thesis, which I think I agree with, is that human nature is building a perception of the intelligence and capability of who or what they're interacting with by their use of language.
Yeah.
And how articulate and sophisticated that use of language is. We are creating a projected perception of intelligence.
Yes. Yes. So we label all of this stuff as artificial intelligence. Some people twist it around and say, no, it's augmented intelligence. But we have that word that the I is intelligence. And certainly where we are today, arguably there is very little intelligence there. It's all effectively, a large language model is very good at predicting the next word.
Mm.
That's what it does. And it does that based on a huge wealth of information that it has been trained on. That doesn't necessarily mean that there's intelligence there. Now, where we're headed with different ways that these systems could move, I can see how intelligence and sentience, if you like, could. I'm not saying it will, but I can see how it could generate over time, with models basically doing self-reflection of and different agents, and models talking to each other and as I say, self-reflection. I think there are ways that we could get into a very interesting world in the future.
I
and
think
there are all sorts of implications.
in
of
some ways,
that.
we're already in quite an interesting world. We seem to be
yeah.
getting into it very quickly.
Yeah.
Just if it's okay with you, I want to come back to this point regarding maybe other humans who don't have the ability to grasp or leverage language that may not portray their depth of intelligence. So you suggested a good example is maybe an autistic or a type of psychological behavior that would say there is a massive intelligence and capability that's hugely underestimated by the fact that they are unable to articulate and leverage language in a way that would portray their level of intelligence.
Yeah.
And like a simple example, and I'm trying to work out whether this is even relevant. If I'm in another country, unable to speak their language, and I kind of try to ham-fist my way through a Spanish sentence or a French sentence, are they naturally thinking that my intelligence level is lower than it actually is because I'm unable to articulate what I need and want with their agreed structure of language? So like, do you understand? If there's an intelligence level here and a language level, humans, there's a huge diversity. Hugely intelligent people maybe are unable to articulate. Hugely articulate people who maybe aren't as intelligent as they portray. That's actually adds a whole complexity to basic human interaction. Never mind the interaction with artificial.
So we'll get onto this. One of the reasons I find this whole area so fascinating is because it really makes you think about us as humans.
It does, doesn't it?
And
it's a mirror.
And how the brain works and how you rapidly get past the this person doesn't understand what I'm saying, therefore they're stupid. You rapidly get past that into a let's try and work out different ways that we can communicate, and whether it's using your arms or motions or whatever it is, you get to a level of understanding. But I do think, back to what we were just saying, I do think that we make initial judgments based, and a lot of those judgments are based on the linguistic capabilities. So when a large language model, coming back to the AI, comes back to you with a well, if you like, reasoned sentence and response to a question, it's very easy. In fact, it's quite difficult not to go, oh well, it's just matched that pattern with the pattern that I've asked.
It's credible.
It understood what I was saying. Well, it didn't. It understood what I was saying, and therefore it's given, from its intelligence, it's given me an answer.
Interesting. So I think that, would we both agree that AI, or certainly generative AI, has a sophisticated, it's got a sophisticated way of using words and language that makes us as humans perceive it has intelligence.
Yeah.
So just to step back a little bit from large language models, because so we're at this point where we've got an agreed sense of understanding. We are perceiving intelligence through its sophisticated use of language and its sophisticated ability to predict language. The next question I think is important is where does that language come from? Yeah. So within a generative AI model, how does it know the words and how does it vector the words? Where does that style and structure originate from within that transaction?
Whatever the data that you gave it, that it was trained on in the first place. So if you train it on a whole stack of data that's come from social media, and you will get you'll get the language, you will get the biases, you will get the opinions, all of that will be built into the model. If you curate, if you're careful about the data that you train the model against, so you rigorously go through the data and you take out stuff that is not relevant, stuff that let's be honest, stuff that you don't want to be in there. Now, whether that, let's stay aside from the politics of whether that's right or wrong, but so, you know, if you're wanting a model to work for enterprise, then you don't need that to be trained on social opinions and things. You need it to be trained against business data or academic data or whatever it is. And so fundamentally, and this goes all the way back to the early days of machine learning, fundamentally, the quality of your AI depends on the quality of the data that you trained it against.
It creates a concern for me.
Yeah.
The highly utilized and high growth of the open internet, essentially free AI models. When I look at those, they're closed. You don't know, certainly from looking at the key mainline ones, OpenAI's ChatGPT, for example, which I use frequently, which after the conversations and learnings I've done over the last week, I'm starting to second guess, because my concern is that the data that's been processed behind that generative AI and all of the buttons and tweaks and slider bars and tones, all of the variables that define the style of the language.
Yeah.
So the objective data set and the configuration on how language is used, which I've had transparency of in the work that we've been doing, and it's kind of overwhelming in how the slider bars and the tuning parameters can create a huge spectrum of change in responses. So if we're in a world where we are sacrificing transparency for ease of use, we're rushing into leveraging OpenAI products to help augment us right now, help us create documents, help us prepare for difficult conversations, these sort of things. It's those responses, which in some ways we're leveraging, are being trained on data and a whole load of settings that we just don't know what they are.
No.
So it concerns me that I've rushed into this easy use AI model and I'm quite seduced by its language and therefore perceive intelligence. However, getting under the covers, I'm starting to realize there's a whole set of configuration parameters that I don't know who or why or what they've been chosen.
Yeah. So I would say, configuration parameters is one thing, but really core is the data and the quality of that underlying data. But let's take it back out of AI. Let's take it back into human interactions. So I'm not feeling well, so I go to the doctor. Well, why do I go to the doctor? Why don't I just Google? Okay, because the doctor has been trained. I use the word trained against medical data, and is a more trustworthy person to go to than to go to social media. And so in many ways we're at the point where these generative AI systems are, we have a choice as to how we deal with them, and that choice is very similar to how we behave in our human interactions. Do you want to go to somebody who knows a bloke in the pub and that's where I'm going to get my financial advice from, or am I going to be a little bit more rigorous about my research as to whether to invest in Bitcoin or whatever it is, and different people will come to different conclusions, but at least we have that choice as to where we go and what tools we use.
I try not to Google health issues because I always end up quickly thinking, am I on the verge of an immediate cardiac arrest, or I've got some sort of underlying brain tumor or something in my body that's causing these symptoms. For some reason, online search always seems to get too catastrophic very quickly, which actually in its cycle of causing additional anxiety then seems to proliferate the symptoms of whatever I'm suffering from anyways. So just we're getting into this point on training data What does training mean?
Basically, training. One of the reasons why the generative AI has really taken off is because you can use basically any data, and with a huge amount of compute power, it will work out what the patterns are and that within the data. Prior to that, all of our AI, our machine learning, if you like, was based on what we call labeled data. So in other words, for example, we all know that if I apply for a loan, then the bank will take some details from me, and in the background, a little machine learning model will go through all of my characteristics, how much I earn, where I live, et cetera, and work out whether I'm a sensible person to give them to loan money to, or whether I'm likely to default on those loans. So that is the reason why that model works with a degree of confidence, is because they've got a lot of information that says these people paid their monthly dues, these people didn't. And therefore I can look at the characteristics of the people that did and the people that didn't and compare them against each other. And that will give me not a you can or you can't, but there's a probability that these characteristics is, well, if you like, a higher risk than these characteristics. And we can argue whether that's right or wrong, but based on the data. Now, that's predicated on having that data saying these people defaulted and these people didn't. Now, if you move to the world where I'm asking any sort of question, where do I get that label data from? And the answer is I get it from potentially, if I'm just looking for label data, I need armies of people. We're all part of this. How many times have you been asked to identify the number of traffic, the pictures with the traffic light to prove that you're not a robot? Yeah. Traffic lights, bicycles. What's that data being used for? It's being used to train cars, intelligent.
Oh, interesting.
Cars.
I didn't know that.
Yeah.
I didn't know that. Isn't the one with the cookies and the dog, where the cookie and the dog kind of looks the same thing?
Yeah.
And only humans can determine whether it's a cookie or a dog. And now AI knows, because I've told it which one's the chocolate chip cookies and which one's the dogs.
Absolutely.
Maybe explain to me this training on unlabeled data and how it creates language.
So to do that is expensive in terms of labeling the data, but building the model is relatively cheap. It's not, you don't need a lot of compute power to do it. Now, if I have that data and I need a lot more of it, if I'm not labeling it, I need a lot of data, and then effectively use very clever algorithms to work out all of the patterns in the data and to work out that all of these pictures are in fact pictures of dogs because they have these characteristics, and these are pictures of cookies. I need a lot of data to do that, and I need a lot of compute power to traverse all of the possibilities within that. And that's why these models are big and they're expensive to run.
Because somebody's spending money on compute power to process data to create a model that allows it then to replay the syntax and the structure based on the data it's learned. So if you read the entire works of Shakespeare, then you would be able to create an AI that was ye olde and speaking that old English, because it has vectored the language it's learned on.
Absolutely. And it's an expensive thing to do in terms of compute cycles. That's why you need GPUs, because they are the most efficient way of getting compute cycles rather than CPUs. And those GPUs absorb large amounts of power.
Why are GPUs better for AI than CPUs?
Simply because of the number of compute cycles that they can compute in a short period of time. A CPU is able to do more generic things at more. is able to do more precise things. A GPU is doing a lot of very simple things very quickly. It comes, G is graphics. It's from doing graphic processing. As you probably, my two sons are in gaming and they've got their GPU, their own built PCs. They were really quite angry after the Bitcoin. So GPUs,
the miners use GPUs.
The Bitcoin miners use GPUs because for that very reason. And so GPUs became expensive because of the amount of resources, the amount of GPUs that were being taken out by the Bitcoin miners. And as soon as that started to tail off, all of a sudden Gen AI appeared to go, we'll have all of those GPUs. And of course, the price of GPUs shot up even further. On top of that, these GPUs, they absorb power like nobody's business. So I think I heard recently that Microsoft now reckon that in their Azure sites, that around 30% of the consumption is due to AI, Gen AI.
Training,
training and using. So for using, we talk about inference. Yeah, but the combination of both.
So
yes.
this is really interesting.
And there's work that was done actually before COVID, looking at the trajectory of how these models are getting bigger and bigger and bigger, and as the model gets bigger, that means you need more GPUs to run it. As they get bigger, and our use of GPU of AI increases dramatically as well, the combination of those means that potentially, if we carry on the same trajectory, somewhere around 2035, 2040, all the electricity produced in the world will be needed to power Gen AI.
AI seems to be phenomenally good at promoting itself, even within the YouTube algorithms, within the social media algorithms. Some of our videos were about the dangers of social media and how we're hooked, and they don't seem to do very well. And the ones that talk about the amazing impact of AI on this utopic ending for humans seem to just go wild on the algorithm. So there's something in me that thinks as AI gets an increasing bandwidth of computational capability, as it starts to find its own bottlenecks, it will look for solutions. So power, for example, if as these large language models and hugely complex Gen AI start to grow in their reach and influence, and it starts to hit limitations like its ability to provide, to source power to continue growing, there's something in my mind that thinks it will find an answer, which could be good for us as human beings inhabiting the planet.
So you're infusing like sort of sentience in the AI, that the AI will find. We as engineers across the IT industry, we will find ways of solving that problem. And one of the more obvious ones at the moment is that to do specific jobs, you don't need big foundational models that can do everything. You need a foundational model that will do the task that you want. And again, I keep on putting this back to people. We don't expect people to know everything. We expect the doctor to be good at medics. We expect the engineer to be good at building things. We expect the artist to be good at painting, or whatever it is. And there are, there are one or two people around who are, the Renaissance type, Da Vinci type of person who is very good at all sorts of things. But most of us mortals, we're specialised.
So let's
And AI, I think, will definitely be heading into that specialised. We'll have specialised AI for doing different things, and then we'll have networks of those AIs, and that will get us away from this this big ramp. Inevitably, we'll find new technologies as well.
One final point on the engineering behind these services, which I was quite interested in just discussing a little bit more before we get into the impact of language model design, is that there seems to be two clear workloads under an AI, training and inference.
Yeah.
As I understand what you've told me is the training is where algorithms are processing data to build a map, an atlas, vectors to allow it to replicate that language that it's being taught on. And inferencing is the actual process of responding and interacting and replicating those models that it's learned from the learning process. Is that kind of a good... So GPU power that's being consumed is basically doing two processes, training and inferencing.
Yeah. And you might need hundreds of GPUs to do the training piece, and you might need one or two, or, you know, depending on the size of the model, a handful of GPUs to do the inferencing piece. So, so as we've already talked about, the training process is big and expensive. And, you know, some of the models that we all know, and I won't say love, but, you know, that we all know, they've taken hundreds or thousands of GPUs running for weeks.
So how are they going to get their money back, Gemma? They've capitalized huge amounts of, I assume, billions of dollars into GPU infrastructure, access to information, processing and training of that information to be able to provide us an inferencing capability that helps us write our CV, prepare for difficult conversations, create videos, create pictures. How are they going to commercialize the inferencing process based on the capital expenditure of training?
Well, I mean, there are lots of different ways that could happen, but fundamentally, if we're using those systems, we are providing value. We become the product. Everything we say, do, is going to be used as, you know, potential advertising revenue, and then in a commercial environment, those systems are sold as, you know, productivity gains for an organization or whatever it is.
It feels like there's a whole business opportunity for anyone or anything with legal access to information to work out how that information could be used to train and then create value through the inferencing, the interaction with. And like whether it's medical, climatic, historical language data. So do you think we will see the emergence of, to one of your previous points, very focused inferencing services? Inferencing is my new favorite word now. Or AI services that are based on very deep domain specialized data sets that have been used to train those models to then create very focused services.
Yes, absolutely. So they might be legal, or they might be medical, or they might be, you know, client-based, or climate-based. So lots of different potential use cases. But what I guess one of the concerns that I pick up when I talk about this is, well, does that mean we're going to replace doctors, or what are we going to replace? And I absolutely don't think we're going to do that. But if you think of, particularly in public service, you think of how much of our public infrastructure is under stress at the moment, how many of the, what we might call knowledge workers, people who have skills in particular areas, how overloaded they are with work, and a lot of that work is trawling through information. These systems are very good at making sense of that information, summarizing it, suggesting actions based on that. So if you think of all of the things, the sort of things that hit the news on a scarily regular basis about whether it's medical, whether it's social services, whether it's policing, and where things with hindsight, people go back and say, well, if we'd have known that and known that and known these four different things at the same time, we might have identified something and saved somebody's life, or whether that's, as I say, medical, whether it's policing, whether it's social services, whatever it is. And we've got lots of people who are completely overloaded in terms of what they're doing. And there is, to me, this is the real value of these types of systems as they stand today. We can really help that type of.
I think this is a really contemporarily important topic when you look at the stress on public services, the stress across the emergency services, policing, all of these elements. And I think what you're suggesting is we need more knowledge workers who are augmented, not less workers replaced, which I agree with. One thing I would say is that we start to move into an area when we're starting to apply technology augmentation in very, very, very personal and human scenarios. When we talk about public sector, it is the sector for public, whether it's transportation, policing, courts, healthcare. There's a myriad of systems, but they are orientated around serving the human. In the scenario where this isn't an application of AI within a machine, but it's actually interacting with people and the communities and people, we start to become sensitive to, really sensitive to the training data, biases, and also, and I would like to talk through bias in AI and ethics in AI, and I think this is a good time to do that, but to challenge the whole thing, any model that is built upon previous experience and retrospective data, by its nature, is bias. If I give you the definition of bias, which I'm sure there are many definitions of bias, I'm questioning whether this one is an unbiased definition of bias, but it refers to the natural inclination or prejudice being prejudgment, for or against something or someone without conscious intent. And it can arise from personal experiences or social conditioning. So in some ways, like, let's be super objective about whether biases are a good or bad thing. You could argue we've survived because of bias, or we could also see these negative biases where people are treated in a way that as an individual they don't deserve based on a data set that may not represent them. So it's a very difficult and very personal area, so very sensitively treading through it. But objectively, from a technology perspective, how do we ensure that these public sector workers who are augmented with AI are being augmented in a fair, unbiased way that keeps them safe and supports them in their jobs, but supports the services that they're trying to deliver? And this is a very complex subject that we certainly, but do you get a feel for where I'm trying to solve for?
Absolutely. And the film Minority Report?
Philip K. Dick's, amazing.
So
my favourite author, I think.
So there are concerns in this space. Absolutely there are, and there should be. So let's talk about that bias. So bias is not, I think, my personal view, is not an inherently bad thing. Let's go back to machine learning, all right? I'm trans. I haven't changed my legal name. my passport says male, and my bank won't put anything other than my legal name on my bank card. That's my bank. But in terms of machine learning, if we take, well, I mentioned boots, my Advantage card labels me as somebody who buys makeup. Yeah, they don't care about what, if you like, my labels are. They care about how I'm shopping. The data is not lying about the fact that I buy basically female beauty products and whatever it is. So Amazon, will look at me in terms of what I buy. YouTube labels me not as this person with these sets of gender markers and whatever. There isn't, if you like, there's a bias built into that, but it's built in around my behavior, which me given I'm talking about retail examples, as a customer, I'm quite happy with that, because it means that I get targeted for things that are relevant to me, or actually what it means is I don't get targeted on things that I really don't care about. That's great, okay? That's in a retail environment. Now let's move that into something that's more related, and if we keep to the gender basis. So for example, in the HR space, machine learning, before Gen AI, machine learning models have been used over time to whittle down CVs. So case in the States where effectively they did exactly that. So lots of people applying for jobs. You need some way of getting these thousands of applications down to something that's manageable from an interview perspective. So you take all of your successful CVs from the past, and exactly what you say, what the machine learning model then effectively does is to aim to replicate the existing state of affairs. So if the existing state of affairs is that you've got predominantly a white male workforce, then that model will be biased to create the same sort of, it will pick out, these were the people who were successful before, therefore let's pick out people who are similar to that. There will be a bias. Now,
are we not at a pivotal point where there's an opportunity to focus these type of technologies on active behavioral data as opposed to static identity data?
Oh, yes.
And let me take a scenario. For an example where you're talking, the HR example you're using, if we take away these static data points of areas where discrimination can be created proactively or retrospectively, age, gender, any static point. If you actually start to think about like active behavior, output at work, hobbies that may include team efforts. So, maybe even by the fact that I'm trying to be prescriptive on behavior, I'm becoming biased in my own model that I'm creating. So but I guess where I'm going is, if we're trying to have a deep respect for the individual and their wishes, which feels morally correct.
Yes.
And we operate within a framework of rules, which businesses and society kind of requires to thrive and create equality, then behavioral traits within those structures feel like the right data sets to be processing, to be more prescriptive in creating tools that would augment these workers.
Absolutely.
So, for example, whether it's police or ambulance, it's not about the identity of people, it's about the system of data around them, maybe the time of day, the situation. functions that would be more prescriptive to the necessity to operate a certain public function.
Yes.
Maybe that came across really badly, but
No,
if we just move away from identity to behavior, it feels like we have a much more naturally aligned system to provide services that, in their very nature, aren't dealing with things that would cause discriminatory behavior.
Absolutely right. And coming back to, if you like, comparing these systems to how we behave as humans, that's exactly how ideally we would behave socially with each other. I'm
trying to think of a good example. Maybe if you had a vehicle that had the ability to control its total speed and its performance based on a set of data, you could say, and let's say your insurance policy was associated, you could say this is somebody under the age of 20.
Yep.
They've only been driving for 6 months.
Yep.
I'm going to take static identity data and say I'm going to limit this car to a certain performance, certain things, right? So straight away, that person, individual, has been prescribed a certain vehicle characteristic or capability based on some static identity data that doesn't account for the fact that this person has actually lived on a farm, they've been driving vehicles for 10 years, they're extremely experienced, they're actually a performance, blah, blah, blah. But despite those static data, they're getting an inhibited service.
Yeah.
Whereas if the vehicle was more analysing real-time behaviour, and it was realising braking distances are being adhered to, there's no over-aggressive acceleration. So you're starting to create these key points that analysing. And then it said, well, based on behaviour, I am going to adjust my capabilities in line with the behaviour of the driver, independent of static data points about the driver. It's being much more aligned with behaviour. Now, that I may be creating a massively oversimplified model, but it feels that would be a lot safer.
Young men are statistically more likely to have a crash, but why should we just say, well, you are under 21, and therefore your insurance premium is sky high, and that's why they offer black boxes.
So real-time telemetry data.
And the black boxing is doing exactly that. It's, are you cornering too fast? Are you accelerating too hard? Are you braking too hard? Or are you, how many sort of shocks, dynamic shocks are there in terms of near misses or whatever? Are you fundamentally, are you a careful driver? And then you get charged, if you like, from an insurance point of view. Your premium depends on how good you are at driving, not on your gender or age or whatever it is. So and of course it's AI or machine learning that's doing all of that processing of that data. But you can see how that type of that approach can then lead into lots of other environments.
It makes me feel that the advent of high performance and real-time compute makes machine learning based on static data points feels lazy. It feels lazy. It feels like a first generation of intelligent planning based on static data points, but we know it's flawed. If we move to something that's maybe more real-time, telemetric based on behaviors, it feels a step forward in terms of avoiding unnecessary biases based on static data points.
And going back in time, we haven't had the technology that could handle that amount of data in real time and whatever. So we're, having been in IT for the 40 odd years that I have, there's a lot of stuff that you couldn't do 10 years ago. You absolutely couldn't do 30, 40 years ago because the technology wasn't there. Well, we have the option now. So there's not a technical excuse for not doing that.
And it's moving to transparency and openness on how this stuff works.
Yeah.
And certainly working with your team and this last few days, I've realized that maybe you could help explain a little bit about all of the configuration behind these models, temperature, these different, the slider bars. It feels like we used to have really hi-fi systems with all different equalizers and different points, and nobody wanted them anymore. They wanted, Steve Jobs' iPod, which completely obfuscated, and we trusted them to provide us with equalized sound that was perfect for our listening. Is AI going to continue in that obfuscated closed model? Because to me, it feels so important that we understand the transparency of the data and the systems that allow us to control the behavior. It feels so important that maybe do we need to come back to a more open, complex, but open way of understanding the way this works?
I think you can still be transparent without making it overly complex. So yes, there are, in terms of how a model works, you can effectively change what the tuning capabilities effectively are doing are changing the mapping, or changing the priorities, if you like, the weightings of different things within the model, and it's deeply complex. It's not just you need a data scientist, but you need a data scientist who understands neural networks, and so I don't see that we're ever going to go to the point where all models are open and that everybody's got all of the knobs to tune and everything. Having said that, I do think it's important that an off-the-shelf model, if I could call it that, is then defined with this is the way it has been tuned, but critically, this is the data it was tuned against. Because I come back to that data thing. If you don't know what the data was that went into the model, then you don't know what the model's going to do. And so that data side, I think, is critically important. And then in terms of how you engineer the model, there are the knobs and the tuning, if you like, that you can do. But the other critical thing, we talk about prompt engineering and prompt tuning, which are ways of effectively telling the model how to behave, but doing it although you can code it in Python and whatever, doing it in a much more linguistic way. So you're effectively, instead of just going to the model and asking a question, the question you're saying, right, you are a medical assistant talking to a patient who hasn't got a clue, and so giving, if you like, context, and giving more information about how the model should respond to particular questions. To capture all of that information is not difficult, and to make that open and transparent to how that model is being used for. So it may be you're using the same model, but for a particular purpose, you've tuned it, you've engineered it in a particular way. Capturing all of that information, I think, is critical. And it's not, I think, regulations are obviously, where next year we have the EU AI Act, and that will change, and there'll be more stuff coming over time and elsewhere in the world as well. We need to have that regulation to ensure that these things are used and are engineered, if you like, properly, that we understand the risks involved. And from a commercial point of view, if I'm going to use a model to effectively to present my brand to the outside world, I need to know that that model isn't going to swear. I don't need to know that it's not going to say bad things about my organisation to undermine my brand. We've seen lots of examples of that already. And so from a commercial point of view, I need that transparency to be able to say, yes, this is a model I'm prepared to use, or no, I'm not going to use that model, but I am going to use this model over here.
It feels there's an opportunity, a global opportunity to create standards on how the end user understands what data or what level of data has been used to train these models. It feels that there needs to be a standard way of communicating that to normal people who don't necessarily exist within engineering teams.
The one concern I do have in this space is that the rate that the technology is moving at and the rate that traditionally regulatory bodies move at are chalk and cheese. And so the regulatory bodies need to be able to respond more quickly than they do at the moment to the changes in technology. Otherwise, the technology will just keep on outstripping the regulations.
To have met you and listened to your insights, it gives me great comfort to know there's people with the level of experience and maturity behind some of this technology. It's been fascinating, your perception of language and intelligence and how there's maybe a potential dislocation there. But based on some of the points you've made, as we sit here, do you believe the rate of adoption and development of the technology will lead us to a utopia or dystopia?
I'm generally speaking an optimistic person, and therefore I would say there are concerns. Bad actors can use this technology in bad ways. I think that we as a species, if you like, will prevent that. I'm of an age, as a kid, I was brought up in the Cold War. I was brought up in the Cold War. The Middle East was always on the point of blowing up. Well, some things don't change. And the world was, we could have destroyed ourselves so many, many times over with nuclear weapons. That potential was there. There were bad actors who had nuclear weapons. There still are bad actors who have nuclear weapons. But as a species, we've always pulled back from that. And is this as dangerous as nuclear weapons? Yeah, I think it is. In terms of how, it could be used. But I think that we will prevail.
On that, Gemma, thank you so much.